In Unit 1, I gave you an assignment where we had some workers who were shoveling wheat out of the back of a grain truck. And what I wanted you to do in this assignment was identify 2 engineering controls that would, in essence, eliminate the hazard, 2 administrative controls to protect the workers who were shoveling wheat in the heat, and then 2 personal protective equipment controls. Again, we always want to control at the highest level, the engineering controls being at the highest level. You guys did a really good job on the assignment, but I wanted to do a follow-up here and share some of your ideas and maybe some other ideas that didn't come up in our in the papers that were submitted. Again, as safety professionals, a lot of times we are going to be faced with scenarios like this where we have a work process that is not as safe as it could be for the workers. Again, shoveling grain in the heat. I think I gave you 94-degree heat index. They were out in the full sun, full solar loading. It's a dangerous type of environment. In Oklahoma, there are at least a couple of work-related fatalities each year, and this is the kind of circumstances where that could occur. But a couple of engineering controls that I wanted to share with you. Some of these you came up with, some of these you didn't. But with engineering controls, we're eliminating the hazard ideally. One of the simple controls, if possible, is replace the standard flatbed grain truck with a dump truck, a bed with that will dump, or a belly dump. That takes the workers out of the back of the truck, that takes the shovels out of their hands. They just pull up to the elevator, they dump their load into the elevator. Another option is a type of trailer called a live bottom trailer. Now, use a live bottom trailer in areas where you can't use a dump bed. We use a lot of these in asphalt production, asphalt operations. A lot of asphalt paving jobs, there were overhead power lines, there were trees. You could not use a conventional dump bed because it would make contact with overhead obstructions. So we used a live bottom. Here's a video of a live bottom trailer unloading wheat at a grain elevator. Bear with me just a second while I bring this up. Let me pause this, go into theater mode, and there we go. But this is a live bottom trailer. I don't think anybody mentioned the live bottom. We talked about a couple of students brought up dump beds or belly dumps in their papers, but no one did the research and found out about live bottom trailers. And that's part of this process. When you're faced with a work process and you're not completely familiar with that work process, that's perfectly fine. Happened to me all the time. When I went to work around asphalt plants, I had to learn about asphalt plant operations. That was my first real opportunity to use live bottom trailers, was in our asphalt operations with Kiewit. So just because you don't know, that's okay. Do the research. There's a wealth of information out there that's available to us. Do the research. And there's a good chance if you do that research, you're going to come up with something innovative, something that will help keep workers safe. But here's a live bottom trailer. And this is kind of maybe a longer video than it should be, but I want you to see it from beginning to end. And the gentleman here standing at the back of the trailer, he is very glad that he has a live bottom trailer, because he might be the guy up there with the shovel. Because this is a grain elevator, they can't use a dump bed. If they try to use a dump bed, it's going to cause damage to the building. The opening is not big enough for a dump bed to elevate. But here we go, live bottom trailer. And you really can't tell what's happening here until it gets to the very, very end. I could fast forward it, but I want to give you a better understanding of how much shoveling it would take to empty this trailer if they didn't have this live bottom. I just thought of something. If you're in my class and you can email me 2 of the hazards associated with grain dust. There's 2 specific hazards that are most serious with grain dust. Email me those 2 hazards associated with grain dust. I will see if I can't find some extra credit points for you. The first person, and not everybody, the first person to email me the 2 most serious hazards associated with grain dust. And if you grew up in Oklahoma, you probably should be able to nail at least one of them. See, we're getting toward the end. Now this particular live bottom has a panel that moves back with the conveyor belt. There's a conveyor belt in the bottom of this trailer, hence live bottom, but there's also a panel that pushes the wheat back as the conveyor is turning. There we go. Trailer is unloaded. Great engineering control. You don't have anybody back there with shovels. You don't have anybody exposed to the heat. And again, it's a fairly common technology that's used, not just for grain, but like I mentioned before, the asphalt industry. But okay, there are really 3 engineering controls. Dump bed and belly dump, they're different. Several of you mentioned belly dumps. That's just a trailer that has an opening in the bottom of the trailer, and they are designed so that once that belly is open, gravity will allow the wheat, or it could be rocks or gravel or whatever's in the trailer, the gravity will help those materials come out the bottom of the trailer. Another option is a truck tipper. You will see this at a lot of larger elevators. Not necessarily the co-op in Buffalo, Oklahoma, but a lot of your large elevators at like the port of Catoosa, or a large port where trucks are coming in and they have to get those trucks unloaded quickly. They will tip the whole truck. And here is a video of that. There we go, tipping the whole truck. You get the idea. And I don't think anybody stumbled onto this engineering control either, but it's another good one. It's not going to be appropriate for every facility where grain needs to be unloaded, but if a lot of trucks are being unloaded and you need to do it quickly and safely, the truck tipper could be an option. Another option, I don't have any videos of this, but a vacuum system. You could design a vacuum system to vacuum the wheat out of the bed of the truck. And that's probably, we've already got live bottoms, and we've got truck tippers, and we've got dump beds. The vacuum system would be another possibility, though, for unloading this truck full of wheat without putting guys or women in the back of the truck with a shovel. Administrative controls, and I'll move a little quicker here. Work rotation, share the load, have multiple workers that are sharing the work. If possible, and it's usually not going to be possible during wheat harvest, you're working around the clock during wheat harvest, but if possible, work during a cooler time of the day. You might be able to have some type of shaded canopy or awnings installed to protect workers from the sun. Another administrative control would be mandatory rest breaks or water rest shade breaks. OSHA uses this acronym here, WRS, for water rest and shade. All of these are administrative. The problem with administrative is that it takes someone to make the decision to do it. Someone has to install the shaded canopies and the awnings. A manager has to make the decision that the crews are only going to work during the cooler times of the day, which is just about impossible during wheat harvest. Someone has to make the decision to manage that work rotation and to pay attention to how much time workers have spent in the back of the truck and make sure they get water, rest, and shade breaks. And when wheat harvest or hay hauling season is hot and heavy, there are a lot of managers out there that aren't going to be very generous with breaks, aren't going to be very generous perhaps with water or shade either. So the administrative controls, though, those aren't going to be as effective as what we have with the engineering controls. And finally, we have personal protective equipment. Many of you mentioned full brim hats, clothing to cover exposed skin. You did really well on the personal protective equipment. This is where a lot of companies start looking for controls, though. I do have to mention this. A lot of companies, they don't think about administrative controls or engineering controls. They go straight to personal protective equipment, which is the least effective method. Again, it requires the worker to wear the hats, to wear the clothing properly, to wear the neck shades. Other options include vests that are on the market that can help lower that core body temperature. Bandanas that can be put around the neck. Nobody mentioned this. It's probably not widely known unless you're in the safety profession, but there's a technology called a vortex tube that can be mounted inside of a suit, and that vortex tube connected to compressed air will lower the temperature inside that suit 20 to 40 degrees. It's very effective cooling just with compressed air and a vortex tube. You may be thinking, well, that sounds like an engineering control. Well, it's really not an engineering control because somebody's got to put the suit on, somebody's got to make the decision to hook up the air compressor to the vortex tube. Workers have to take action in order to protect themselves, in essence. With engineering controls, workers don't have to make a decision at all. The truck tipper does it, the live bottom does it, and there's not any decision making beyond that's involved in the process. And in the assignment, I told you that we couldn't use water spray. You'll see these misting systems in some workplaces where they have a steady stream of mist that's blowing over the workers, mist and fans and all of that. Well, you can't use that with most grain operations because it will ruin the grain. They look at the moisture content of the grain, and if the moisture content of the grain is too high, that can ruin the whole load, the whole batch. So you couldn't use water spray in this specific situation. Now, in other situations, maybe water spray would work. Finishing concrete, a fine mist of water spray, possibly, as long as the water wasn't flowing too rapidly or at too high of a volume. And there may be other applications as well where water spray could be used. Just wanted to give you a quick follow-up to that assignment. So let me know if you have any questions.